Hi everyone, and welcome back to this series of short videos devoted to CytoPipeline, an R tool for building and visualizing pre-processing pipelines for flow cytometry data. In this video, we are going to extend our visualization capabilities. Indeed, we are going to demonstrate another shiny application which enables to visualize scale transformations and possibly proceed with some manual adjustments to some of them. So, let's get started. How do we launch this new shiny application to visualize scale transformation? It is via this statement here, CytoPipeline GUI Scale Transform app. So indeed, the Scale Transform app shiny application is part of the CytoPipeline GUI package. And here we find back the dir parameter, which basically specifies in which directory the application will scan for scale transformation lists. So let's run the statement. And this launches the shiny application where we have this kind of layout. So here again we need to specify the CytoPipeline experiment, so the CytoPipeline run in which we will visualize scale transformations. So let's select HBVT demo 2C. And the next step is to specify which scale transformation list object we want to visualize, and this visualization needs to happen on a specific flow frame because it will generate visualization as a distribution. So here, so the application is scanning for all the objects that were generated during the scale transformation queue of the CytoPipeline run. And so here we only have one scale transformation list, which is the outcome of the processing queue. And next step is to select the flow frame. So again, the application will scan for all flow frame objects that were generated in the process of the scale transformation list queue. However, if there are no such flow frames, which is the case here, then the application will generate synthetic data sets. That is basically created through the aggregation of all the different sample files followed by subsampling. So here we have synthetic aggregated files coming from each pre-processing step that was run during the HBVT demo 2C experiment, so the CytoPipeline run. So we can select any of them. Let's decide to select the last one, which is the outcomes of pre-processing. So let's visualize our scale transformation on the outcome of our pre-processing. So next step is to select the channel which we want to visualize. So let's say, for example, FCA. This is a forward scatter, and so typically the scale transformation generated for such channels is a linear transformation. So in this case, linear transformation, we have access to the slope parameter and intercept parameters, parameters that were generated in the process. Okay, let's note that we can visualize the scale transformation on the original range of the data, or have a look at the range of the data after application of the transformation. So here we have a range between 0.5 and 1.5. Okay, so let's go back on the original range and move on to fluorescent channels, for example CD8. So in that case, typically we have applied logical transformation and not a linear transformation. However, this we can change manually if we want to visualize changes on the transformation. Let's note that in terms of transformation type, for the time being, there are only two transformation types that are implemented here, but we plan to add new transformation types, for example, arcsinage. Okay, so let's assume we want to manually adjust those transformations for some of the channels, and we want to save the results. And for example, let's move to CD4, and we say, okay, this interval here between the two modes is a bit not large enough, let's say, and so let's try to play with those parameters here. Let's see, okay, I want to increase the positive, okay, but this creates strange behavior. Let's move on to this. Okay, so here is a nice transformation. So then in that case, let's apply temporarily to the channel in memory and move on to other transformations. Okay, this one, for example, let's move on, apply to channel. So let's know that when we have applied our change to the channels, then if we come back to those channels on the screen, yes, we can see that those parameters have been saved in memory. Let's now assume that we are okay with all the transformation list, all the transformations of the transformation list. Let's then save our results. Hopefully the window will pop up soon. Yes. Okay. And save our results. Here, my scale trans list, let's say, in the temp directory. Note that we save the outcome as a RDS file, which is a format for an R object. Okay. And that's it. In this video, we have demonstrated the use of another Shiny application that is part of CytoPipeline GUI and which enables the visualization of scale transformation and possibly the manual adjustment to some of them. In the next video, we're going to elaborate on a few technical elements that can be used to fine-tune the run of our CytoPipelines.